I'll be showing you and walking through the various features in Structure101 in the various components. My objective really is to give you a good understanding of Structure101 and what its purpose is and how you would use it and what have you. The details of the user interface and the commands and things do take a bit of getting used to. So I would encourage you to look at the online help that you'll see in any of the products. You can click the button somewhere and it'll take you to the usual documentation pages, which go through stuff in a fair amount of detail. That's always a good place to start. And also contact support at structure101.com. You'll get a very good response there. That's for general purpose usage of the details of Structure101, or if you've got any problems, just go to support. For now, I'm going to go through some slides that lay out kind of what Structure101 is about and what are the key concepts, if you like. Then I'll show you some of the key measures. A typical way to adopt Structure101 is you start gathering data about your projects at build time, and you accumulate those in a Structure101 repository, it's called. And then you've got a dashboard to that repository where you can track the numbers. And then after that, you will be aiming to reduce the numbers, improve the numbers, if you like, in a few ways. And we'll talk about that as well. Then we'll get into one of the components called Workspace, which is the one that's closest to the developer. And we'll talk a bit about that and the basic workflow for the developer using the visualization. Then we'll be doing more challenging restructuring type work and creating specs for your project. And those specs, again, will be captured in the numbers and that type of thing. So a little bit about Structure101, the company. We've been around for a while. We're not a large company. We're quite small, but we're distributed. Most of us, I guess, nearly half would be in Ireland, but we also have guys in France and India and Spain, UK, Canada, last time I checked. We also have channel and technology partners. One of our technology partners, for example, has created the JavaScript TypeScript backend. Lots and lots of customers around the world. The key point here is, I guess, that the product is very mature at this stage, continuously evolving. We put a large part of our revenues go back into developing the products and improving the products. It does work for Java, which is what I'll be focusing on in these training sessions. We also support .NET, C, C++, JavaScript, TypeScript, and we have a generic version of the product that's used for other things, let's say. So first of all, the name, Structure101, we aim to help you deal with structure, software structure. So it's worth talking about what we mean by that. Most static analysis tools tend to focus, for the most part, on problems with specific lines of code. So that'll be one or two or a few lines of code to find problems. Maybe you've got potential bugs in there. Maybe you've got security vulnerabilities and that type of thing. And it's trying to find those really at the lines of code level. And the key thing there is that once those potential problems have been highlighted to you, you can go in and look at those problems in your IDE. And if they need fixing, you can go ahead and fix them in the IDE. All you really need to know is that the problem was detected, and there's a bit of a description or an explanation typically of that problem so that you have an idea of how you might go about repairing it. Structure, on the other hand, what we mean by structure is something that emerges from many lines of code. So it's really across the whole code base. And really, when you get a problem with the structure of your code, it's not typically related to individual lines. It's typically related to lots of lines, and you need to understand a lot more about the overall dependency structure of your code base in order to do that repair. So what you really need to understand the structure of your code base, and then to improve it and specify it and really make use of it is a model that spans the whole code base. So that's kind of what we do. What you need is a structural model of the whole code base. So when we find things that are not quite right with your code, you need to be able to get the big picture. And that's what Structure101 will be providing for you. You won't find those kind of problems inside the IDE alone. It's just not possible to understand the structural issues by just looking at the code. Okay, so what we do there, first and foremost, we visualize the code base structure for you. You'll get a browsable model so that you can understand the code as it is today. You'll also have the ability to restructure the code. That may mean make some changes to the code that hopefully are minimal amount of changes, but that will improve the overall structure, reduce, if you like, the overall dependency of your code. Then building on the visualization, we also let you specify which are the good dependencies, which are undesirable dependencies, what is the ideal layering of your code, what is the API into modules and that type of thing. You can specify all of that stuff so that your developers get guidance as they're changing the code. And also so that you can detect very quickly when there are violations to the architectural specifications. And finally, and well, in a sense, maybe first off, we measure the code. We analyze the code at build time so that you can understand the nature of the structural complexity, how much of your code has been specified, how many violations to the specs have you got, and track those numbers over time so that the structure improves as time goes forward. So what we're trying to get to is large projects, typically the structure gets very complex and it tends to work against development. When you're going up to 1 million lines of code or more, the structure of the code can be a real problem for your developers. They don't understand what's going on. Everything seems to depend on everything else. They're fighting with the structure. If you guys can improve the structure of your code, you will find that the structure actually becomes an intrinsic part of the quality of your code base and starts helping your developers. It helps them to understand those 1 million lines of code a bit better. Okay. So very briefly, this is kind of an abstraction of what we do. We pull out the dependencies from the source code. So obviously, you know, you can find out what functions use this function as you're developing the source code. We also build into that the containment structure. So in the case of Java, you've got your functions or methods are encapsulated into classes. Classes are in packages. Packages are in higher level packages, etc. So we can start understanding which functions in this folder use which functions in that folder type questions. We build on top of that some specifications which help us understand things like what functions violate the API that I've defined for this particular module or component, that kind of thing. And then on top of that, all within the same model, I can start manipulating the model. So I can figure out, understand, and simulate how I might move files and functions around to repair either specification problems or complexity problems or whatever it is. Okay. The sort of things that people use Structure101 for. First of all, understanding your code base. Second of all, find and resolve overcomplexity. Now, overcomplexity is stuff that's just generic to any code base. It doesn't really matter what your architecture is supposed to be, although you typically wouldn't design an overly complex code base, right? But it's a sort of a separate objective measure of complexity is what we will provide. And we give you ways to find and resolve that. Finding and resolving that makes your code base easier to understand. It makes it easier to specify. It makes it easier to do things like break up monoliths that are in your code base. So that will be another major use case. Another one might be to extract a module from a monolithic module. So we're going from a monolith to a modular monolith, if you like. You're pulling stuff out, but you're making things very modular. You're all the time trying to control dependencies. Dependencies are uncontrolled dependencies are one of the major sources of complexity in any Java project. Okay. And you can do other things like evaluate divergence from a library. If before you're looking to pull in a new version, you can analyze the impact of changes. Where should I be retesting? There are all of these kind of things that you can also use Structure101 for. The main components are Workspace, which would be used primarily by programmers or people wearing the programmer hat, let's say. Studio is, if you had to give one role for Studio, you might say architect, but absolutely any seasoned developer will get a lot of value out of Studio, depending on the activity that they're working on. We have a dashboard, which I suppose is for the managers and team leaders. It tracks aspects of your structure over time, okay? And then Build. And there's another thing called Soda, which is in the pipeline and currently being released, but I'll just mention it for now, which is kind of used for everybody. It's a way of capturing information about the structure of your code at build time, okay? Just go briefly through each of those, and then I'm going to actually show them to you, so I won't spend too long on these. But what you'll notice with Workspace is it's giving you a way to browse the details of your code and the dependencies within your code through the architecture. It's really joining those worlds of architecture and programming so that you're doing the programming and understanding all of those details associated with a specific JIRA in the context of an architecture, which may be the de facto architecture of the code as it's been developed, and possibly with the addition of some specs that have been created for the project using Studio. It will show you structural problems, and you can navigate from those problems within the Workspace user interface to the visualization. You can find them in the visualization, and when you spotlight something in the visualization, you immediately see all the dependencies going in and out from that item. And you can navigate from anywhere inside the visualization of the model to the source code and back again, okay? You can also understand what just changed. So when you make changes, you can see what is the impact of that code change that you just made on the overall structure of your code base. Did I just create a whole new dependency from one package to another that wasn't there before? Because if I did, well, did I mean to do that? I'm starting to go away from the dependencies that are already established by the programmers on the project. And specifically, if I create a new change right now and that change creates a new cyclic dependency, then I should know that. If I am violating a spec or a module definition, I need to know that immediately, ideally before I check in those changes. Moving on to Studio. Studio is a much more elaborate and more powerful component to the product suite. There's a lot more things you can do in Studio. You can analyze, you can specify, you can repair problems. You can specify and check APIs, you can find over complexity, you can break up monoliths, you can create and simulate repairs. In other words, you can do all of the intellectual effort that's required to make a substantial architectural change, like you've got a monolithic module of maybe 1 million lines of code. Maybe I want to pull out one feature from that line of code into its own module. There's a lot of work you can do within Studio before you even go anywhere near the code. So that simulation step is essential, because if you're doing those kind of changes right in the code all the time, then the chances of you completing, or at least the cost of completing a major restructuring job, tends to be an awful lot more than if you simulate it first within Studio. Typically, you can use Studio all by itself, but where it really kicks in is you can use Studio with Workspace to pass action lists and specifications and what have you down to the programmers who may be using Workspace, so you can share it in that way. Build is a headless utility. It looks at the code, it looks at the specs, etc., that you've done in Studio, and it looks at the previous build of the code and does an analysis at build time. So you're checking the new code against the specs and, if you want, against the previous version, so you can figure out, are there any new problems that have just cropped up in the latest build of your code. Check new code for over complexity, record structure and violations in what we call a Structure101 repository. And you can also publish to common quality platforms such as SonarQube. Finally, there's Dashboard. Dashboard sits on top of the repository and lets you view the data that is captured in the repository. You can track the structure over time, or at least you can track structural patterns and anti-patterns and violations and stuff over time. You get a list of violating items, so you can see immediately what are the violating items, but almost more importantly, you can see the red and green numbers there. They indicate what just got better or worse. So that's very important. It lets you find out, was there a new violation that went into last night's build? There may be thousands of violations there, but at least let's not let things get worse. How do all these work together? Well, your source code is grabbed potentially by Build, but Studio and Workspace can actually go straight to your source code as well. But either way, a structural model is created. If you're using Studio and an architect wants to, and when he's ready, he can create specs and actions, and they're shared in a sense back to the structural model. Workspace would typically be used by the programmer, and he can see if there are specs and actions, they will surface and be visible and affect what he sees inside Workspace. And he can use that information so that he's, in effect, understanding the architecture as planned for the project as he's making code changes, so that he's programming in the context of that architecture. And finally, the managers and the rest of the team, to one degree or another, will go to the dashboard to understand what's changing. Are things getting better? Are we converging on our targets? And that type of thing. So, overview then of the tutorial. So I'll move into showing you some of the products now as a next step. First thing we'll look at is the key measures. So I'm going to start with the dashboard. It shows you some information about your code base, about the structure of your code base specifically. Then we'll go into using Workspace for understanding dependencies and understanding how the dependencies are changing as you're changing the code. And also you'll see how you can find and repair simple overcomplexity using Workspace. Workspace will give you the information you need in order to simplify your code in some circumstances. In more complex circumstances, you want to be using Studio. Then we'll go on to Studio and we'll see how you can do basic analysis of your code base, used for all kinds of purposes. You can also plan a restructuring activity within Studio. What you're doing there and what restructuring means and what is the goal of that restructuring may be generic, as in we need to improve the overcomplexity issues that are being highlighted, or it may be very specific to your project, where you know now it is time to break this monolith out, pull a particular component out of the monolith and move it into its own module, that type of thing. There is also speccing. Now, speccing needs a human. In order for us to say you have an architectural violations, you need to define an architecture. You do that in Studio. And then we'll show how this work you're doing in Studio can be propagated to Workspace. So key measures we're going to look at now. I'll go straight into that in the dashboard. I'll just use the dashboard here as a way to talk about the key measures that are captured. They all surface in the other components, but I'm just going to show how they're captured, if you like, on a per build basis. What you see here on the right-hand side is a list of the key measures. So there are a few generic measures here, things like the approximate lines of code, the number of classes in the project, and that type of thing. Then we're into some of the generic problems. Actually, these are specific ones, but the better place to look at these, I'll just point out here, you can click on any of these and it adds or removes the information or the trend for that item. It goes onto this tracking over time widget here, the trend over time. So you can see all that, how are things going here. An interesting one here that may not be obvious is percent specified. That's an indication of how deep into the structure your structure spec for this project has gone down. So you can create a structure spec at the top level. You might have, let's say, a dozen modules at the top level. You can define the layering between those modules. You can create groupings of those modules. You can make some of them private to other modules. You could allow and disallow different dependencies between the modules. But you can also go within those modules and start specifying the structure of the packages within the modules, the package structure within those modules. As you go deeper, the percent specified goes up. And that's what that is there. So you might initially, with your projects, plug in build into your build pipeline. What you'll find is that the percent specified is 0. And that's okay. You need to know that, but that may be perfectly fine for now. What you would probably want, and you can maybe set targets for this kind of thing, is, look, guys, let's all get to at least 40% specified in the next couple of months for each of the projects. And what you'll typically find is when the percent specified number goes up initially, the number of violations will go up because you've created a specification. And now there are some violations to that specification that need to be repaired. And that's what a very typical pattern is that. And then later on, you'll see it come down again. That's what happened here. Actually, if I remove the feedback dependencies here, what you'll see here is the percent specified went up, which in a sense created some violations of that specification. And then it didn't change much for a while. And over that time, the number of violations decreased, which is fine. And now I've just deepened the spec. I've gone down and added more specification to my model, which has, in a sense, created some more violations of the new bits of the specification. And so there'll be another period then where it'll probably hold up at this level, and we'll get the violation count back down again. So that's that part of it here. You can see if you have a structure spec, it will appear in the user interface here. And here are the specific problems that have been detected in the last build. And you can see the general count is 32. It's grouped in this way here. You've got 3 major groupings here. You've got the structure. They are the objective measures of overcomplexity, if you like, the structural problems. And they'll be there or not there, regardless of anything else you do. They're going to get tracked. If you want, you can ignore them. They may not be that important to you, but they're there if you want to. Then we have the structure spec related issues here. They'll be 0 if you have no structure spec. But as soon as you create a structure spec, now we're going to need to keep track of the dependency violations. And likewise with modules, you can switch this on or off in Studio. If you are monitoring modules and you have some module definitions and you're switching on certain types of checking about the modules, then these will kick in. And the other thing is, whenever you click on these, you'll get the list of whatever they are. You can see there's 6 here, for example. There are 6 feedback dependencies kind of going on here. There's a 3, a 2, and a 1. And I also see the change from the previous build. So we made some improvements here. It looks like 16 of those got better, were removed. And that's the case in all of these here. You can see there are some red numbers. Plus plus means that there's a problem that wasn't there in the previous build that's there now. A single plus on the number means that it was there before, but it just got worse. A single green means it was there before, but it's got a bit better. And a plus plus green means it's been removed. So you can see probably a few, yeah, there's a few down here, the minus minus, these are ones that have been removed, okay? And so you can see that for feedback dependencies. So these are tangles. This is where you got cyclic dependencies between packages. And here's the list of the packages that contain those problems, okay? Then we've got fat. Fat is too much stuff at one level of decomposition in your project, okay? And we'll see what these look like in a moment in Workspace. And then the spec is, if you create a spec, it implies a whole bunch of rules about what can use what. And where you've got dependency violations, that will indicate that you have broken the rules that are implied by the spec, likewise with modules. So I'm going to leave it at that. That's sort of an overview, if you like, of the kind of stuff that we're going to capture. And so in a sense, as well as understanding your code base, you're going to be using Structure101 to chase these numbers down, prevent them from getting worse, ideally. So that's where we're kind of starting. So we're looking at Workspace here. And if I look here at the project, I have this is IntelliJ. I guess you guys probably use IntelliJ or Eclipse. Over here, we have the Explorer. We have something similar, right? So this is typically how a project is organized. At the top level of the project, we have a bunch of modules here. And that's what we see over here in the tree view as well. And we can drill into any tree view here just by clicking the expand as you'd expect. It goes right the way down into the various classes and interfaces, and actually right the way down to the methods and fields within that, okay? So that's kind of the same as what you're going to have in your IDE. So I'm just going to hide this for the moment because it's kind of the same here. We don't really need that. Down the bottom here, we've got all the same kind of problem lists that you had in the dashboard. You've got your tree view here, and in here we call this the structure map. And I'll talk to you now about what that is. When you're working in your IDE, you have an alphabetical list here of the modules at the top level. And every time you expand, it's probably going to be alphabetical as well. You're going to see the classes within the packages or the packages within the packages, that type of thing, in an alphabetical list. It tells you precisely zero, really, about the dependency structure of your code that you're looking at. That's where Workspace kind of kicks in now. It's adding to your world an understanding of the dependencies. So now what you're seeing at the top level here, I'm using a mouse wheel here just to scroll. And when I mouse over any of these modules at this level of the visualization, these are all modules, I'm seeing the dependencies. And they're actually organized into dependency levels or layers, so that at the bottom, we've got core here at the bottom. It doesn't use anything else. So it goes to the bottom. And then anything that uses core but nothing else goes on to the next level up. And then after that, everything uses at least one thing on the next level down. So it's a common way of doing dependency graphs, really, but it gives you a way to understand something about the structure of your code without actually seeing all the dependencies all the time. And in fact, here you can switch on the dependencies from this thing here. There's all the dependencies, but it tends to be very cluttered, okay? If you don't do that, then you can select what problem dependencies you want to see, or you can just mouse over, which is what the default would be. You can also spotlight by doing a control click on any of these items here. You can see just the items. It does a filter on the whole model so that you're only seeing the items that either use or are used by the item you spotlit. Okay. And so you can do that at any point in time. And you can click into things. So you click on things, it starts expanding. Okay, so here you've got the package structure. So I drilled into this module here, and now I'm seeing the packages within the module. And at each level, it's levelized. So logging goes at the bottom because it's used, but within Headway, within this package, the sub-package logging is at the bottom because it doesn't use any of the other sub-packages. Util uses logging. Brands and Foundation use util. Brands and Foundation have no dependencies between them, therefore they're on the same level. Then we've got this red box here and some red lines showing up. This is a tangle. There are cyclic dependencies between these three packages here, which means they can't be strictly levelized. So we put a red box around it just so you understand that the levels that you're seeing are not 100% accurate. They are kind of accurate because we minimize, we lay these out, so assemblies at the top, then CView, then widgets, so that most of the dependencies flow downward. But they don't all flow downward because you can see here, there are still some upward dependencies here, and that's what they are. And then we've got tools sitting at the top. And I can drill in all the way down. I can see here, I'm just sort of randomly drilling down, I guess, here. Once I go down inside classes, I can see the methods and fields within the classes. I'm now going to do Spotlight again at this level. When I spotlight down at a code level, if you like. So a code item means a class or a method or a field. It'll not only filter the current view, it will also expand the current view all the way down to the same level. So if I spotlight on a method, I will effectively see all of the methods that use or are used by the item that I just spotlit. And I can navigate around here, get location, etc. here. I'm moving around the code base, if you like, to see all of the dependencies. Maybe go command click here, save, execute. So I guess execute is the beginning of the thread here. So you can chase dependencies around, and then you can go back. If you can't remember where you came from, you go backward and forward, okay? So this visualization here can grow very big and it can get quite small, etc. But that in itself tells you something about what you're looking at. It's the number of dependencies is kind of one of the key aspects in a sense. But also you're seeing those dependencies through the package structure, through the module structure at all times, okay? Navigation then. What you need to do is there's a lightweight plugin that you'll get called a connector, the Structure101 connector. You'll install it into IntelliJ or Eclipse, and it allows you then to click this button here. When you start up, this thing here will be red here. This link button will be red, and that will indicate that you're not connected. So you click it, it turns green, and now you've got a link with your editor. And if I go back to where I was, let's say I'm looking at a visualization here. At any point, then once this connector is hooked up and it's green, I can alt click on that to take me to that code. So execute here. Save was Spotlight, so that means that execute is using save somewhere. If I go to execute here, I see save verily, there's a call to save there. So that's the way that kind of works. I can also navigate back the other way. So for instance, what have I got here? If I go to this one here, I've set it up to do an alt click. The alternative is you can find it in the menu here. Show in structure map, that's the same thing. So I'm just using a shortcut key that I set up for that. So remove column, if I make a change to remove column, well, here, let me make a bit more space over here. If, I'm not going to be impacting too much stuff, okay, I can see that. I can see it uses this calls thing here. It uses the list-driven table column class down here. And it's called by these things up here, which are all within something called notables, a package called notables. They're all within my current module core. Okay, that's fine. I probably wouldn't hesitate to make that change. If I go down here to, let's say, clear and do an alt click. Now I can see there are a few more dependencies here, and not just that, but I'm actually got some incoming dependencies here from other modules here. The Java parser and the C++ parser are also using clear. So that may be relevant. I need to know that if I'm making a change here, if it's a breaking change or it requires more testing or whatever, I can kind of judge that directly from the visualization. And then if I go down here, I think this one has a whole load more changes here. This one here I can see is used very widely across the current module. So there's core. Core is my current module there, but also these other modules up here. So that's the basic navigation. I just want to show you a little bit more about the changes then. So what happens when I make some code changes? What's going to happen here? So let me just go back home again here. And then we're going to go into core here, headway, and let's have a look here. So these two here, foundation and brands, are side by side. That's because there is no dependency between them at the moment. I'm going to create a dependency between those two packages by drilling into one of the packages and a sub-package again. And I'm going to go into this elementary metric here. And I'm going to make a dependency from it to this class called branding here. I'm just going to create a new field. So let me navigate to the class here. And you can see I kind of pre-prepared that here. You need to do a compile in order to update the model. So I'm just clicking the hammer there. You might have automatic compile set up. I don't. So you do a compile there, and then I'm going to hit one of, there's a refresh, a full refresh and an incremental refresh. So I'm just doing an incremental refresh here. And you can see now what the effect of that incremental refresh is. You can see that this purple color indicates something has changed. It's a solid purple, so it's kind of bolded purple here, brand, meaning that is a brand new. Since the previous time you hit refresh, I have a new field in here, and it's using that branding class here. So that's what that is there. So it's a new thing called brand of type branding. I'm going to just do an undo over here, and I'll just look at that at a different level. Let me undo there. Don't forget to compile, hit refresh here. We go back to here, and I can see the impact now. I'm going to just collapse this here so that I see the effect at the higher level package level of the dependency map. So let me compile that, and now I do an incremental refresh here. And watch what happens. Brands and foundation were side by side. Now foundation has been pushed up because it has a dependency on brands. It's been moved up in the dependency levels. So that's the key point there. Okay, this is just so you got a basic feel for the levelized visualization. Next, we're going to start applying that to finding structural complexity and doing exciting things like extracting a module from a monolith and that type of thing. But I think that's probably a good coverage so far of at least as far as the basic understanding of your dependencies and how they're changing.